So up to this point, we've talked about converting permutations from one-line notation to two-line notation, from two-line notation to one-line notation, and a single permutation from cycle notation to two-line notation, or from two-line notation to cycle notation. The last topic we need to discuss before being able to talk about the Futurama theorem is the idea of multiplying cycles that possibly have some overlap. So here you'll see that, the number 6 appears more than once. The number 2 appears more than once. In the example you saw in the last video, all numbers appeared in exactly one cycle. Here we have some repetition. We can think about this as composing or multiplying cycles. And so that's what we're going to talk about in this video. The main idea to keep in your head while you're multiplying cycles is that it always goes right to left. We're going to start at the rightmost cycle and go one cycle at a time to the left until we reach the end. And how we're going to do this is one number at a time. So we're going to first think about what happens to the number 1 from right to left. Then what happens to the number 2 from right to left. And so the first thing I want to do is I want to start at 1. I don't see a 1 in the first cycle. I do see a 1 in the second cycle. And in that cycle, 1 goes to 5. So I've started at 1, and I go to 5. So now I'm at 5. In the next cycle, nothing happens to that 5. In the next cycle, nothing happens to that 5. In the next cycle, nothing happens to that 5. In the last cycle, nothing happens to that 5. And now we're at the end. So we started at 1, we ended up at 5. That means overall, 1 goes to 5 in this permutation, or this product of permutations, if you want to think of it that way. Next time through, we want to consider what happens to the number 2. So we're going to start at the number 2 and see what happens. Well, in this first cycle, I do see a 2. What happens to the 2? It goes to 5. So now I'm at 5. In the next cycle, what happens to that 5? It goes back to 1. So now we're at 1. Nothing happens to 1 in the next cycle. Nothing happens to 1 in the next cycle. In the next cycle, we see that 1 goes to 4. So now we're at 4. And in the very last cycle, we see that 4 goes back to the beginning, which is 7. And now we're out of cycles. So we're completely finished with processing the 2. The 2 ends up at 7. So 1 goes to 5, 2 goes to 7. Next, we'll consider what happens to the 3. If you're starting to feel comfortable with the process, I recommend you pause the video, figure out what happens to the 3, and then press play when you're ready to check your answer. But first we see that the 3 goes to 6. Then nothing happens to the 6. Then the 6 goes to 7. Nothing happens to the 7. Nothing happens to the 7. And finally, the 7 goes to 2. So we started at 3. We ended up at 2. So 3 goes to 2 in our 2-row notation. Next, we'll consider what happens to the 4. Nothing happens to 4 here. There's no 4 here, no 4 here, no 4 here. Finally, we find a 4, and it goes to 3. And then nothing happens to the 3. So 4 ends up at 3. Next, let's consider the 5. First, it goes to 3. Nothing happens to 3 here. Nothing happens to 3 here. Nothing happens to 3 here. Here we find 3 at the end of the cycle, so it goes back to 1. And then nothing happens to 1. So 5 ultimately ends up at 1. Now let's look at 6. 6 first goes to 2. Nothing happens to 2. Nothing happens to 2. 2 goes to 6. Nothing happens to 6. Nothing happens to 6. So the 6 ends up at 6. Next, we consider what happens to the 7. So we'll start at 7. Nothing happens to 7 here. Nothing happens to 7 here. 7 goes to 6 here. 6 goes to 8. Nothing happens to 8. And then 8 goes to 4. So the 7 ends up at 4. Finally, we're ready to talk about the 8. What happens to 8? Well, nothing happens to 8 in the first cycle. Nothing happens to 8 in the second cycle. Nothing happens to 8 in the third cycle. Here we find an 8 that goes to 2. Nothing happens to 2. And then 2 goes back to 8. So at the very end, 8 ends up at 8. So when there are repeat numbers in our product of cycles, we have to make sure we process from right to left, not from left to right or in random order. It must go from right to left, one cycle at a time. Figure out where each number ends up. So finally, in 2-row notation, the bottom row reads 5, 7, 2, 3, 1, 6, 4, 8 for this product of overlapping cycles. In the quiz for today, you'll get some practice with these multiplications and also with some of the conversions from the first 2 videos. And then tomorrow, we'll put it all together and actually see what this has to do with the problem you saw solved in the Futurama episode.